the part 1 of this Doppler radar video, we have seen what is meant by Doppler effect and why there is a change in frequency when the vehicle is moving towards or away from the listener. So in this video, we are going to see how the radar uses this Doppler effect to calculate the speed. So for that, let's consider two scenarios, and here you can see that the vehicles are moving, and in first scenario the speed of the vehicle is less as compared to the scenario 2. So here speed is less and here speed is more. So let's wait for the animations to start. Here you can see that the clustering of the frequency is more less as compared to in this case. So that means that if the speed is more, that means that the clustering will be more. So the speed has a relation to the clustering of these frequencies or the frequency increase. Here you can see that there is less clustering, the frequency increase is less, but here there is more clustering and the frequency increase is more. So the speed and the Doppler frequency shift are like directly proportional. So this concept is used to calculate the velocity in the Doppler case. So to analyze that, let's consider a scenario. So here we have a radar and we have the target here. So in case of the radar is usually stationary and the target will be moving towards or away from the radar, and we have to calculate the velocity of this target using the Doppler shift. So this is our scenario. So this is our target and the target is moving. So this is the basic principle of radar. Radar will be transmitting an electromagnetic wave and it will be hitting on the target, and based on the target properties, some part of the wave will be reflected back. So this wave will be processed by the radar to calculate the range, velocity and angle. So based on the movement of the target, there will be some change in the received frequency, and that is used to calculate the velocity of the target. So let's see that. To calculate the velocity of the target in terms of the Doppler frequency, we are considering this scenario. We have a radar and we have the target here, and this target car is moving towards the radar, and initially the distance of separation between the radar and the target is r. So for a single cycle, that is for a wavelength, the phase of one cycle is 2 pi. So here for this wavelength, the phase of this cycle is 2 pi. So if you are considering the distance of separation between the radar and the car, the total number of cycles from this radar to the car and back depends upon the total distance between them. So based on the distance between them, the total number of cycles which can be occupied between this space depends upon this distance. So here you can see that this total number of cycles actually depends upon the distance, and here you can see that based on the distance, around 3.5 cycle of the uh, waves are occupying in this space. So we can see that the total number of cycles within this distance is can be given by 2r by lambda. We are considering 2r as we have to consider the to and fro motion as it is the radar case. That is why it is 2r by lambda. That is the length of each cycle. So the total phase can be given by 2 pi into n, where 2 pi is the phase of a single phase. So depending upon the number of cycles which is occupied in this space, multiplied by 2 pi can be given the total phase of the wave in between the radar and the car. So as we are considering, this car is moving towards the radar. So here you can see that the car is moving towards the radar and the distance of separation between them is getting reduced. So here you can see that the total number of cycles occupied in between this radar and the car is getting reduced as the distance of separation is getting reduced. So we can see that the total number of cycles which is occupied in between them can also be given by 2r by lambda. Here r become r1, that is the new distance of separation between them. So the total phase can be given by 2 pi into n. So here you can see that as the distance is increased, total number of cycles are getting reduced, and that is the total phase is also getting reduced. So we have seen that as the distance changes, there is change in total number of cycles or the total phase occupying in between the radar and car. So this phase difference we can use to calculate the velocity of the target. So let's see how it is done. So we know that the total phase shift is given by 2 pi into n. N is the total number of cycles in between these things. And we have seen that total number of cycles depends upon the distance of separation. As it is in the case of radar, it has to calculate to and fro motion. So the total number of cycles is given by 2r by lambda. So substituting in here for the phase difference, we can get total phase is 2 pi into 2r by lambda, that is 4 pi r by lambda. We know that as with respect to the movement of the vehicle, there is change in phase. So we have to calculate the change of phase. So this change in phase will be corresponding to the angular frequency. So the angular frequency WD is given by d phi by dt. So we know the equation for d phi. So we are going to differentiate that, and this angular frequency is related to the Doppler shift by 2 pi fd. So here in this equation we can see that 4 pi is a constant and lambda is a constant. So only the variable here is r. So the r is varying as this car is moving towards it. So based on that, it becomes 2 pi fd equal to 4 pi lambda dr by dt. So this dr by dt is corresponds to velocity because this is the rate of change of distance with respect to the time. So here you will get 2 pi fd equal to 4 pi nu by lambda, and from this you can get Doppler frequency shift is equal to 2 nu by lambda, where this is the velocity and fd is the Doppler shift and lambda is the wavelength. So using this equation we can calculate the velocity. So if we have these equations, by rearranging we can get the velocity of the target as fd into lambda by 2. So this is the equation to calculate the velocity of the target using the Doppler shift. So the Doppler shift is helping us to calculate the velocity of the target in case of the Doppler radar. So that Doppler effect forms an important role in radar calculations. That's all. Thank you.